believe we can start, folks. It's exactly 25 minutes, and I have lots of content to share, and I have only 20 minutes, so let's start. And I'm here to talk about web AI, artificial intelligence straight in the browser. And before ever introducing myself, let me try to catch your attention by this quick demo. It's pre-recorded just for simplicity of the logistics. On the right-hand side, you see web application hosted on Vercel in the browser, and it's a purely front-end application. There is no any kind of backend, just what you see on the browser. And this is just a task manager with NPU tab enabled. And we are going to run very simple, let's call this classic task on image recognition. What's going on this picture? And in this simple UI, I have a couple of settings, like choosing the model we need to do this recognition, choosing respective APIs from WebGPU or WebNN or WebAssembly, and a couple of more parameters, but these are just details. And I can tell you that I didn't spend too much time on optimizing this demo, like choosing proper model, proper parameters, everything. So it works more or less just as is out of the box. And that's not the main part here. The main part will happen when we choose one of the web APIs available for AI stuff, and one to understand what happened and how you can build something similar, maybe tonight. I'm Maxim Salnikov. I just arrived to this amazing event from propagate bare metal functionality to a web platform, right? But if I remember correctly, it's around 80 to 90% of truly native experience available straight in the browser. We want support of all possible hardware, but we'll stop on that a bit later. Unified abstractions, exactly what web promises us. We don't want to know anything about model with all its pros and cons, so it's quite low-level API, and you will see that. And also, that would be amazing if this standard works together with what already exists, both on a lower level, like platform native frameworks, libraries, standards, and what's on top of this, like higher abstractions, for example, JavaScript frameworks. And yeah, also, we want something real. We don't want one more standard just to have one more standard. We want this standard to solve real use cases. And basically, list of use cases are just part of this specification. So it was started like by chatting with developers, teams, companies about, hey, what do you want to solve in your project that can work straight in the browser of your customer, client, visitor? And yeah, quite a few use cases. And you see, not all of them are from this hype train related to generative AI, so I like highlighted only one. The rest is what we have available as AI workloads long before this ChatGPT happened. Like say, old gold use cases, maybe not that shiny and inspirational, like generating texts, music or whatever, but something that really works and something that is really useful in real projects. And of course, this standard is not really only one option you have to build in browser AI experiences. So you see this kind of layered pie of what we can call edge AI ecosystem stack. And by saying edge, I mean something that runs on device, not more than that. All starts from the hardware, and we have quite a few silicons where we can run all these workloads a bit later on that. On top of that, we have platform-specific libraries, frameworks, and specific for particular platform, for particular operating system. And of course, this is endlessly far from JavaScript. This is something written in low-level programming language, something that is really platform-dependent, something that you can not take something from Linux and run on Windows. On top of that, we have web engines, both for front-end, our browsers, and of course, JavaScript running on the back-end side via Node.js or Electron. Set of web APIs. This is where World Wide Web Consortium has work to do to basically find the best possible specifications. And if you remember previous slide, WebNN is still in draft, but that's totally normal. If you know how W3C works, some standards that are available in the browsers and actively adopted by developers can be in draft stage for years. This is how that works, so it's not a blocker. Higher level frameworks that already existed and also broadly adopted by developers. Why kind of discard all this existing stuff if we want to introduce something breaking? No. Smart folks who created this standard, they really wanted to have it kind of as a backend for high-level frameworks. And of course, use cases all start from this. About hardware, I mean, there are no devices without CPU, central processing unit. So this is always kind of fallback for AI. Not performant, not really performant, but as it's available, okay, sometimes to run something there, maybe a bit slower. GPU, graphic processing unit. Well, turned out that even though the name says it's for graphics, it's perfect for calculating blockchains and also running AI workloads, like training models, inferencing from the models, and I believe majority of today's devices available on the market, like laptops, desktops, are equipped with quite a decent one, and it's all about performance, right? But it's not only these two. NPU, this is kind of new kid on the block, and this is neural processing unit. This is something that only getting being broadly adopted by manufacturers and users. And for example, this device has this NPU, and also it's even like not a separate chip. It's just a part of like overall processing unit, and it's all about energy efficiency. I'm not saying that NPU, even though it's specifically created for, as its name says, for neural networks, it's more performant than GPU. It depends on the task, but it's definitely more energy performant. So if you don't want to drain your battery on your mobile device or laptop, maybe outsourcing some AI-related tasks to NPU is the best option. For the users, if you remember this, again, multi-arrow slide, we have low latency because we don't have any network trips. We have full privacy because we don't need to send our prompt anywhere. High availability, we no longer depend on availability of some third-party servers. And of course, I mean, it's totally free, right? Once we have device, we can run as many workloads as needed. For developers, we can leverage latest hardware innovations. So now NPU is cutting edge, but who knows what comes next, right? And WebNN is low level enough to support all future AI-related pieces, like maybe silicon, maybe, I don't know, some very specific device. It relies heavily on available platform-level frameworks, like services frameworks, and high-level, like Onyx and TensorFlow.js. And after all, if we are talking about standard, it should like write once and run everywhere. Sorry. How to start? I promised you that you can start something immediately. Well, it's still cutting edge, so you most likely need to install Canary or Dev versions of Chromium-based browsers. So currently it's available in Chromium-based ones only. You need to enable flag, now it's a set of the flags. It's a bit more kind of specific than one big one. And also, if you have device with NPU and want to use specifically this silicon, you also need to update drivers and maybe like run a couple of terminal commands. So, I mean, it's not, let's say, ready for broad adoption for millions of your customers yet. It's kind of in dev mode, but it's inevitably coming. Once we have everything ready, you start coding, right? And you hit something like that immediately. So basically, WebNN is about building and executing operational graphs. So every node of this graph is some calculation, and you have very complex system of how these nodes work. This is definitely far from my comfort zone. So I can really, I cannot create anything with WebNN without me sitting and learning about how these things work, context, operand, graph. But it doesn't stop me and will not stop you from creating something real, because we have higher level frameworks that use WebNN as their backend. And on top of that, we have something called Onyx Web Runtime, in 1 second about that, and even higher one called Transformers.js. And this is maybe the main framework name I want you to remember from my session, because if you start hacking with Transformers.js, you have pretty much everything covered in Web AI on very high level in terms of, I mean, as application developer, you will be able to create something immediately. So what is Onyx? First of all, this is a format of the model. And also on top of that, there are some runtimes to create this model, to run this model, get inferences from this model. And you see that these runtimes are available for pretty much all possible mainstream operating systems, frameworks, libraries. But what's interesting for us is this part called Onyx Runtime Web, where we can achieve the same, but on web platform, both in the browser or in Node.js. If we look how we can leverage WebNN there, well, it's one of available backends. So once we write something in Onyx Runtime Web syntax, we can point to WebNN. Our work with this is much much more convenient, let's say like that. So here we start operating with not graphs, not constructing all these nitty-gritty details manually. Here we have something like inference session. So much more, like, say, visible, right? And but still, it's not really about use cases yet. So it's very generic inference session. Let's go level up and let's check what is Transformers.js after all. So Transformers.js can use Onyx Runtime Web as a backend that can use WebNN as its own backend. So you see, it's like multi-layered pie again when one framework uses another one as a backend, and that's beauty, right? So you decide your own level of comfort. And if you like just regular app developer, you don't want to know anything about data science, data engineering, and not too much about models, Transformers.js is your choice, because this is exactly where we have this use case level. And also, you don't need to ever think about where to grab the model, because it's very well connected to Hugging Face. And actually now Transformers.js is a part of Hugging Face company. And I mean, if you didn't hear about Hugging Face, you must go and check what's that about. Basically, it's kind of GitHub, but for AI models. And you see that quite a few thousands of models work with Transformers.js, and many of them work with WebNN specifically. And also, no problem at all. If you still want to create your own model or fine-tune model, you can host and serve your own one. And also, it has completely seamless caching, because let's be realistic. If you talk about some real AI workload, it's about downloading something on our machine. I mean, today's models, sometimes, in best case scenario, it's like dozens of megabytes, more or less real scenario, hundreds of megabytes, maybe a couple of gigabytes. Also, you will not be surprised, but it's one-time action. Of course, make sure that you inform your user about that. And this is exactly like with literally 3 lines of the code, you can do sentiment analysis, image recognition, lots of things with voice, and there are whole categories of use cases and concrete use cases driven by concrete models that you can download from Hugging Face. I mean, again, you don't even think about downloading, you just point to this, and thanks to amazing developer experience Transformers.js provides, it does all this job for us under the hood. So, summary, before I spend 1 more minute on a totally different way to achieve more or less the same. Web standard for running AI inferences, including generative AI use cases, is available, called WebNN. There are still some moving parts, so it's draft, and for example, device selection is under some, let's say, re-architecture at these days, but don't be blocked by that. Start experimenting, and high-level frameworks like Transformers.js, they will hide all this complexity for you. I believe they follow just all these updates. Demo repos are available. Basically, there are not too much Angular, not too much Next.js. It's more or less for UI, but the rest is just pure JavaScript. I will share, by the way, this slide deck with you very soon, so you will get all the links. But there is a simpler way. Google and Microsoft together support what we call prompt API and writing assistant APIs. This is web AI, or like generative AI possibilities injected straight in the browser. So browser itself exposes these JavaScript APIs, and in that case you don't need to think about model at all, because it's part of the browser, and if you tried something like this in action, you see that the browser first prompts you, okay, I want to download model, are you okay with that? And then you give permission. Idea is the same. It's high level, it's use case scenario with built-in models and slightly different, of course, methods in JavaScript, I mean, compared to transformant.js, but idea is the same. You run something purely locally, purely in the browser. And the code, it's it's quite close. If you look at let's say nitty-gritty details you need or don't need, it's much closer to transformers.js rather than to Onyx or WebNN. You create this high-level object and you run this, and there is a summarizer, there is translator, and few other use cases. But I mean, of course, it's much more limited if you look at use cases, right? It's very, very use case specific. It's not for any general generative AI workload. And this is my main call to action. Folks, this is my LinkedIn profile. Take your mobile phones, send me connection request, or just follow me, you decide. And if you wish to get this slide deck with all the links, samples, etc., just ping me there. Hey, Maxim, I visit your session, just share PDF with me. I'll do it with great pleasure. Thank you so much.